Yesterday when Colin was giving the class presentation, and the prompt of his terminal would show the database name.
Oh yeah, so are you referring to going into the Mongo prompt, like typing Mongo and going into the databases?
And he said he was going to say how we could display that as well, but I don't recall. Did he end up saying it or not?
I'll follow up with Colin later. I'm not quite sure what he was trying to display. We are going to use the terminal and go into Mongo, similar to what you guys did yesterday, and actually see our data persisted. So maybe that'll answer some of your questions. Even though we're going to use this tool called Mongoose, we're still going to go into the Mongo shell, like go into the database itself to check out our data. These are some great thoughts. Any other thoughts before we move forward, just on any takeaways from yesterday? Alrighty, so what is a NoSQL database? Just a quick recap. A NoSQL database is non-relational. So there's different types of NoSQL databases. There's different types of SQL databases. But on a high level, a NoSQL database is non-relational. That means that it has no explicit one-to-one or one-to-many or many-to-many relationships, like a relational database does. We're going to hop into that in more depth when we get into Unit 4, when we actually deal with a relational database inside our Ruby and Rails apps. And I think that that's going to be a little clearer. But kind of the cool thing about Mongo is that it's really much more flexible than a relational database. Relational databases have been around since the 70s, which is kind of a good thing because they're very mature, they're very tested, they're very good for security and acidity. I think Colin mentioned that abbreviation yesterday, that idea of ACID, which is super, super important, and that relational databases do really well. Non-relational don't do acidity quite as efficiently. You have to jump through a few hoops to make that happen, but it's the right tool for the job. So there's definitely cases when you want to use non-relational databases like we're going through with Mongo, or maybe you want to use a relational database. It just really depends on, again, the right tool for the job and your end goal for your application. So all that being said, we can emulate those relationships in our NoSQL database. However, today we're going to look at a little bit of a cooler way to take advantage of Mongo functionality using something called embedded documents. And it makes Mongo super, super fast. And so if we're going to use Mongo, we kind of want to adhere to the best way to use this tool. And that's what we're going to look at today. How is a NoSQL database organized? So a NoSQL database is organized into documents and collections, just like Sanaz mentioned. Collections are the NoSQL equivalent of tables in a SQL database, which we're going to get into that in Unit 4. And documents are the NoSQL equivalent of a table row. Now, one way to imagine relational databases is maybe an Excel spreadsheet. So maybe if we have an Excel spreadsheet called users, then each column in that spreadsheet would be a field or a property for users. And you guys have probably played around with Excel before. So a column may be, first name, last name, address, age, email, things like that. And each row would be a new instance of a user, right? Pretty much how spreadsheets are set up. And that's very similar to how we can think about a relational database. Very structured. Mongo and NoSQL databases are a little more forgiving, which is a really good reason to use it. So if I maybe, for a startup, for example, maybe I don't exactly know today what my data needs are going to be in the future. Well, just to get my app shipped and out the door, get this thing deployed, a NoSQL database may be a good call because it's a little bit more forgiving. Just let me get this app out the door. I'll worry about, more intensive data. I mean, hopefully my app explodes, and that's going to be a good problem to have down the road, right? Like reformatting my database or restructuring my data store. Kind of a good problem to have in that situation. What is MongoDB? So MongoDB is a type of NoSQL database. Did you guys talk about any other types of NoSQL databases? Maybe put them into Slack or come on, Mike. Can you guys think of some other examples of NoSQL types of data stores? Maybe some of you guys have worked on some similar NoSQL databases in the past.
Like key value pairs.
Okay. Yeah, so that's pretty much how NoSQL databases store, particularly since they're written in JavaScript, you can think that they're stored key value pairs. So a key may be a property such as name, address, phone number, and then the corresponding values. Yeah, absolutely. Can you guys think of any other types of databases? Any like big buzzwordy databases that you guys may have heard that would be NoSQL?
XML NoSQL type of database, or XML sort of a storage language of storage style. I don't know.
Yeah, I guess you could store some data in XML. Mongo looks a lot like something called JSON. They look a lot like object literals. They pretty much are JavaScript objects at the end of the day. But just to throw it out there, a couple of other popular kind of hot NoSQL databases that you may have heard of. Did anyone play around with Firebase in their first application? I feel like someone took a stab at using Firebase. Maybe Adam, I'm forgetting. So Firebase, if you want to look it up, it's a cloud-based NoSQL server. It also has some authentication and some other cool features, but Firebase is a really popular type of NoSQL data store. There's also something called Redis. I don't know if you guys have heard of that, but Redis is a really kind of hot, popular NoSQL type data store, and it's super, super fast, and it's really good for something called background jobs. So for example, you know when you sign up to a website and maybe like you fill out a profile, create a new account, and then like 10 seconds later you get some sort of email like, hey, welcome to schmittiapp.com. You know, here's how to change your password. Here's how to log in. So a data store like this thing called Redis, it actually stores the data in your computer's or on the server's RAM. It stores it in random access memory. It doesn't actually write the data to the database because that takes a little bit more time, right? Like, let me write this somewhere in my server hard drive, and then I'm going to go and fetch that data to do something with it. But a NoSQL database such as Redis, for example, stores it in RAM, in random access memory, so it's right there at its disposal. So it can do kind of, we call them background jobs or background processes. It can do that really, really fast. So that's just another example of NoSQL databases. They're really, increasingly popular for sure. Let's move forward. I'm rambling here. So quickly, what are some use cases for NoSQL/Mongo? Why would we want to use a Mongo NoSQL database rather than a SQL database? Let me paste that one more time in here. And we'll give that just a second. Let me do it one more time here. So maybe that screenshot will pop up in just a second. It seems like it's a little slow. So one reason is because NoSQL is very flexible. Again, you don't have to create this thing called a schema beforehand, although you certainly can. A schema is just sort of the instructions for what you want a given model or resource in your database to look like. So maybe if I have users in my database, I want every user to have a first name, a last name, an email, things like that. So it doesn't require a schema, which makes it really flexible, but you can certainly create a schema if you want to make your data more uniform. And it's also super fast, and we're going to take a look at, we're going to structure our database today taking advantage of those features that make Mongo super, super fast. Here are a couple of Mongo commands. You guys went over these yesterday, but just to kind of recap, these are some really popular ones. So show DBs is going to show all of the databases in our Mongo engine, in our Mongo database. The use keyword, use, and then the name of the database, that's going to give us access to that database. Show the collections in that database. And then db dot, for example, students dot find would list all the students in a collection of students. So if we had a WDI remote database, we had an instructors collection and a students collection, we could do a .find to grab all of those instances. All right, cool. Let's just hop into Mongo. So let me show you guys a quick example, and then we're going to be doing kind of a code along throughout the lesson today. So I'm going to be building an app with 2 models, and you guys are going to be building a separate app with 2 different models. So we'll stop periodically so you guys can like update your app and kind of include what I'm doing into your application. But here's a quick kind of overview of Mongoose. So let's face it, you guys. Writing MongoDB validation, casting, and business logic boilerplate is a drag. That's why we wrote Mongoose. So Mongoose is referred to as an ODM, Object Data Mapper. And actually, I've seen this called Object Document Mapper because we're specifically dealing with documents. I usually call it an Object Document Mapper to be very specific. Essentially, it's going to allow us to encapsulate these models that we're going to create, and it's going to communicate to our database and grab instances of those models for us. It's also going to allow us to easily perform CRUD operations. So yesterday, you guys kind of did the longhand way of doing CRUD. Today, we're going to look at how Mongoose can make it a little bit easier, a little simpler syntax-wise. And then here's an example pulled right from the Mongoose documentation, an example of what some Mongoose code would look like. I'll hard paste this in so you can take a look as well. So in this example, we're still going to be requiring the Mongoose module. So we're going to npm install Mongoose. We're going to require it. Here on line 2, we have this mongoose.connect. So connect is the method that tells Mongoose where we want to store our data in our database. In this example, we're just saving our data in a database called test. And then here on like line 4, we're creating a variable called cat. Now cat is capitalized because that's considered a model. This is the capital C cat that all new instances of a cat should resemble. This is kind of what we want our model cat to look like. So in this example, our cat's pretty simple. It just has a name of string. You may want to add some other properties like, you know, type or age or color or name or gender or something, but this is a pretty basic model. We just want to make sure that our cats have a name. And then here on like line 6 or 7, I know there aren't any line numbers in here, we're creating a new instance of a cat and we're calling it kitty. And then we use this new cat syntax, which is essentially like a constructor function like we looked at in Unit 1. So that's another great advantage of Mongoose, is that it allows us to create these constructor-esque functions from these models. So in this example, we can create new cats and name them whatever we want, create new instances of cats, just like we would a constructor function in JavaScript, because this is JavaScript. And then here at the end of this piece of code, we're doing kitty.save. So .save is a Mongoose method, and as you can probably guess, it actually saves that information to the database. It saves this new kitty. And we're going to deal with some callbacks, which I think you guys have looked at in your reading, callbacks and promises. So there's some other kind of syntax that we'll go over, the way that we need to structure our Mongoose queries. But that's basically kind of a very simple example of what we're going to be doing today. So without further ado, let's set up our app that we're going to be coding along with today. I'm going to put this into Slack. So go ahead and take a few minutes and walk through these 6 steps. So I want you guys to create a new project folder in today's Student Labs directory. And go ahead and name this app Mongoose Intro Lesson. And then cd into the folder. Go ahead and create a new directory within that directory called DB, or database, because we're going to put some files in there. And then run an npm init-y. By the way, what does our -y flag do for us? Does anyone recall?
It answers all the questions that the prompt brings to the terminal.
Yeah, perfect. Yeah, so just to be a little lazy today, we're going to use a -y. And then number 5, go ahead and create the following files. We're going to create 3 files to start: an index.js, a schema file in our database folder, and also a seeds file in our database folder. And then go ahead and open up your project in Atom. And there's a screenshot there of what your app, kind of the folder structure should look like. So go ahead and give me a thumbs up in Slack when you get that set up. And I'm also going to be working alongside you guys today, and I'm saving my app in the instructor examples folder. So I'll push it up. I can push it up at break or periodically if it's helpful for reference for you guys.
So I'm sorry, I might have missed it, but are these files we're touching going inside the DB file, or just? Oh wait, you put it down here. I'm sorry, dude. You just screenshot. All right, we're good.
Yeah, no problem. Yeah, I tried to go ahead and set up the touch line, the directory that they need to be in. Yeah, index, we want that in kind of our parent directory. And then schema and seeds, we want inside that DB folder. Cool, we got 13 thumbs ups. Look like we're in good shape. Yeah, Jesse, databases are like one ginormous Excel spreadsheet, it seems. Yeah, that's a good way to think about it. Particularly when we get to relational databases. They're very, very structured, very rigid, very much closer to Excel than perhaps what we're doing today. But yeah, they're very, very similar for sure. All right, we got 14 thumbs ups. That works for me. I'm gonna kind of move forward here. So what we're gonna do for today's lesson, I'll put this into Slack. So for today's in-class demo, I'm going to be creating an app that uses two models, students and projects. So I'm gonna be creating students. Those students have many projects. For example, if I create one of you, you're going to have 4 projects, corresponding to each unit, roughly. So that's what I'm going to be doing as I'm walking through the lesson. We're going to stop periodically, and what I want you guys to do is you're going to be creating the same app, but you're going to be using authors and reminders as your model. So I want you guys to be particularly mindful of, you're not going to be able to like copy and paste the code exactly. Try to think about what you need to change for your authors and reminders models versus my students and projects. And we're going to stop periodically, and also have solution code if you get stuck. But I'll move through it, and we'll be stopping here and there so you guys can add this to your app as well. I'm going to go ahead and start my screen share now, and we will get to it. So here I have my Atom open. Here's my file structure. I have a nice big terminal window down here. I'm probably going to have like 3 windows open at the same time at some points. It can be really efficient. I like to have different tabs open instead of like stopping and starting my servers and such. So I'll give you guys a heads up if maybe you want to follow that practice as well. And then over here I have the lesson. So the first thing I need to do is my app's a little bare. I need to install Mongoose, npm install it. This is actually pretty much the only thing we're going to install for the lesson today, because we're not going to add Express and views in today's lesson. We'll probably be adding views and forms and such tomorrow. So today, everything we're going to be doing is server side. So I'm going to do an npm install, npm, and I'll do a -- save, and I'm going to add Mongoose. It's going to grab some stuff. So Mongoose actually has quite a few dependencies, right? So it's grabbing MongoDB, Mongod, and some other cool stuff. And then I just want to make sure it's here in my package.json. So looks like I'm all good. I'm going to start working in my schema.js file. So to start, this is kind of like the example from the documentation. So I'm going to pull in the Mongoose module with require, and I'm going to assign it to a variable called Mongoose, because I'm going to be grabbing this new instance of Mongoose and accessing different methods and such on it. The first such method I'm going to grab is mongoose.connect, which again, it just specifies which database and where it's located, where we want to save our data. So I'm saving my data in my local host, which just means my local version of Mongo. And for me, I'm going to create a student's database. So I have several databases in my local host. For this specific app, I want to save my students, my projects in a database called students. So I'm going to instantiate that. Cool. A couple of other things I want to put in here. This is just semantics. Mongoose.promise. So we'll talk about promises a little bit later. The reason I'm putting this line of code in here, we're going to come back to it later, but you guys are going to get, when you start running this code, you're going to get some error message, not error, but some depreciation messages. And it's going to say that this dependency called mPromise is no longer valid. You need to do this and that. This one line of code is going to kind of satisfy those depreciation warnings. So I'm just putting that in here. We'll come back to it later. But this line of code, it's strictly, I'm declaring what promise library I want to use. Specifically, this promise library refers to the JavaScript 2016 or 2015, ES6, whatever you want to call it. I'm going to use the native promise library, and that's what that line of code is doing. And we'll come back to that a little bit later. I also want to create a database variable because I'm going to put a few methods actually on this database. Like when I open the database, if there's any kind of errors, if I want to print some sort of message when I exit the database, I can put that type of functionality here. So I'm going to declare a variable called DB, and I'm going to call .connection on it. And then just to kind of be polite and proper, I'm just putting some kind of boilerplate, if you want to call it that, some very basic code that you'll probably want to put in most of your Mongoose type applications. So this first thing is when I first try to open the database connection with this .on method, I'm just passing in this error. So if there is any kind of error, I want to make sure that I see it. So I have this DB on, and I'm passing in a callback function, and it's just saying when I open this database, if there are any errors, just print them out to the console. So remember, with like the JavaScript stack, we have to be very explicit. It's not quite as user-friendly as, let's say, Rails or something where it builds all this stuff for us. I'm also going to add a once method. I'm going to pass in open. So once my database is open, yeah, go ahead. Someone have a question?
Yeah, I got a question for you, Mark.
Sure.
So is error in quotes, even though it's quotes, like it knows that it's not just some random string, like it knows that error means error, like.
Yeah, so remember when we did like event handlers and such, or even in jQuery, when we used the .on event listener, event handler, we would pass in click in a string or hover. So it's that same kind of thing.
Got it.
Almost done here. So I just want to print out a message when I first connect to the database. All this is pretty just setting up your stuff. Database has been connected. So I'm just trying to be polite and give myself some information. If there's any errors, it'll let me know immediately. Once I'm successfully connected to my database instance, I'll get this database has been connected message. So it's just a little bit of work beforehand to set this stuff up from scratch. And so now that this is set up, I can go ahead and test my database, and let's see what this is going to look like. We haven't really done much yet, but let me go into, so I have the app open here. So I'm going to run this line. I'm going to run node, and specifically I want to run this schema file. So I want to run the database schema.js. And so when I hit enter, again, luckily there aren't any errors, which is good. And I do get this database has been connected message, which I asked it to give me that once I successfully connected. So now my application is pretty bare bones, but I am successfully wired up to Mongo using Mongoose. So again, Mongoose is going to be kind of that middle person that's going to take whatever queries we create. It's going to do that math in the middle and actually grab stuff from our database, from our Mongo database, write stuff, read stuff, create stuff, whatever we need to do. And I just want you guys to note, so it connects to the database in this window. I'm probably, for now, I'm just going to leave this window open. So my database is connected. I haven't closed the connection. And I just want you guys to note this little blinking cursor right here. So it may look like it's hung up or it's frozen. It's actually just connected. It's just kind of like hanging out. So that's a good sign. Don't think that it needs to like exit or give you any sort of other piece of feedback.
So you currently have Mongo running right now in that terminal?
Yeah, actually, well, so Mongo is a separate engine. It's a separate thing that you guys installed yesterday with Brew. So Mongo's already, the engine's already running. Mongoose has now connected to that running Mongo engine. So it's saying that the database has been connected. So this specific application is now communicating with my Mongo database.
So Mark,
but you had to.
Go ahead, please.
Oh, sorry, Adam.
No, go ahead.
I was just going to say you ran the mongod command in your terminal somewhere, and that's why it's connected.
Actually, I didn't, and that's something that I want to check with you guys. So I actually use something called Brew Services. So whenever I start up my computer, I just automatically have Mongo start running. I have my PostgreSQL engine starting to run. So that's something that I wanted to check with you guys because I think that you guys may need to do, you may need to fire up your Mongo server. I just have mine running in the background all the time. But if you're getting any kind of error, you're going to want to run mongod in a separate tab. So that's something we can test out right now, which gets us to a little bit of a to-do, you-do time. So we're going to put a pin in it. Let's take a few minutes. We'll get you guys up and running. Basically, just walk through these few steps that I just went through to set up your schema.js file. If you look in the README, all of the solution code is there. There's a little kind of tab that opens up if you just want to. I would encourage you guys just to type it out. It's a little bit more work, but it's just really good to try to get familiar with the keystrokes and kind of the syntax. It makes you think a little bit more about it. So I would encourage you guys to actually type it out. I'll put the finished code in there as well. And then once you guys do that, go ahead and run, I'll put all this in Slack. We'll run node and then test that file. And if we're getting any kind of errors, we'll figure it out. But you guys will probably need to have mongod running in a separate tab. So that's something that I want to check out.
Yeah, I had got an error message the first time, then I ran MonGod in a separate tab, and it's saying it's connected now in the other one. So we won't touch Mongo in a separate terminal window while we're using Mongoose. They're two separate engines, you're saying. So MonGod is we're still dependent on that to run in another window, Mongoose.
Right.
Okay.
So, and I want you guys to, once you run MonGod in a separate terminal, go ahead and keep that tab open. Let the engine run, because if that engine is not running, we're not going to be able to communicate with our database. And then later in the lesson, we're actually going to open another terminal and go into the Mongo prompt and just confirm that like our data is being read and persisted and such. But yeah.
Yeah, that was the tricky part. We didn't see you start MonGod up. That's why when I like first ran it, I was like, nothing's happening for me.
Yeah, we'll take a look at that later. Let me show you what I have. And this is just kind of a configuration thing. We'll probably do this in the next unit, but we could go ahead and do it sooner. So Brew has something called Brew Services. I mean, it's not anything super tricky. I just have this feature, and we'll get you guys set up with it as well. Brew Services list. So I have several engines. I have my MonGod instance. I have MySQL. I have PostgreSQL. I have Redis, which I mentioned earlier. So I have like 4 different database engines on my machine. Sometimes I don't want to like remember to go and open and close each one. So what you can do is you can use this feature of Brew called Brew Services. And then you can add all of these services to that command, and you can do a Brew Services start, and it'll fire up all 4 of these engines. You could do a Brew Services, I think it's stop. I think it's Brew Services stop. It'll shut them all down. So for me, it's just like a little bit more of an easy, kind of an alias, if you will. So I don't have to type in MonGod every time I'm spinning up a new app. But yeah, we can get you guys set up with this later. We usually do that in the later units, but I'm going to stop my screen share for a moment while you guys are working. Yeah, go ahead.
Mark, at the second line, the connect, MonGod, localhost. After localhost, I was expecting like a port. I assume we don't have to list that because like we're just going to default and everyone knows that Mongo is like 2717 or whatever.
Yeah, 27017, I think. Yeah. So that's the default port. So we don't have to specify it here. Mongoose is smart enough to know where we're putting it, where we're trying to connect to the database. Now, make sure that if you look at the solution code, so I'm writing my data to something called students, to a students database.
Yeah, exactly.
I should be doing that different because you're dealing with authors and reminders. So instead of students, what should that database be for you guys?
So I got a question for you. What does that second line like mean? You know what I mean? Like what we've been dealing with is just like databases and collections, and now we have like a path involved as well. So
yeah, sure. Let me put this into Slack. Yeah, Zach, thank you. So you guys just make sure that your path says authors at the end, because remember, you guys are going to be creating an authors and reminders app. Sorry, I just want to make sure we remember to do that, so you're not exactly copying my code. I want you guys to convert it to authors and reminders. Yeah, let's take a look at that line too. Adam, I just put that into Slack. So again, Mongoose is our instance of Mongoose. We're calling the .connect method. And then we pass in the path to the database where we want to save all of the data for this application. So the first thing, it's MonGod DB, which tells us we're saving this to our Mongo database. And then the path, it's localhost, which means it's our locally hosted Mongo engine. There are absolutely Mongo free solutions like in the cloud and such where you can save. There's something called Mongo Labs. When we deploy this app to Heroku, your unit 2s, you're actually going to have to create a new Mongo cloud instance, a cloud database, because you're not going to be able to deploy your app to production and still save stuff on your local machine, right? So we'll change this address eventually. Right now, we're writing to our Mongo database engine, our local version. /students, all that says is create a new database in Mongo and name that database students. That's where I'm saving any data that happens within this app. That's the database that I'm going to save all of this data inside.
Got it. So that's the equivalent of youth. Oh, sorry. Go ahead, please.
It's okay. Go ahead.
No, I literally talk nonstop. Go ahead.
That's right. Go ahead, man.
Let me share my screen one more time. So you guys probably don't have whatever databases you guys created yesterday. That's probably the only Mongo databases that you have. But let me go into my Mongo shell and just let me show you what I have. So I go into Mongo, and then what's the command if I want to see all the databases I have available? What's the Mongo command to do that?
Show DBs.
Yeah, show DBs. So I'll do a show DBs. So, I have several, I actually should have more than this, but I dumped them out. So these are just different apps. These are different databases. So this app that I'm creating right now for our lesson, I'm going to save everything in the students database. When we get to lab time this afternoon, you guys are going to be working on an application called Yum. So you guys are going to have a Yum database. And these are just different apps that I've built over the years using Mongo. So, here's an app, probably a cars application. So I was creating like makes and models and years of cars. Here's a camping store app. This is one that we build a lot here in Atlanta with, a camping store has like, tents and flashlights and canteens, whatever. So this is my Mongo engine because I just connected it. This is my Mongo shell. But inside Mongo, I have 10, 12 databases. So this database, I could go into my code. Let's say that I wanted to save the information for this app in my Yum database. I mean, I could do that if I wanted, and I would just change this to Yum. But I don't want this information in that database. Again, Mongo is pretty lenient, pretty forgiving. So even if that database didn't exist, I could call this Mongo lesson database. I can name it whatever I want. The beautiful thing about Mongo is that I don't have to create, so right now this Mongo lesson database, just for example, right now that doesn't exist, right? I don't have that database. But the beautiful thing about Mongo and Mongoose is that I don't have to create the database first before I start using it in an application. So remember, you guys probably covered this yesterday. Mongo will create the database the first time you try to save something to it. So as soon as I try to run some sort of method or try to create or save something to this database, it's going to go ahead and create it for me. Mongo will do that heavy lifting for me, which is kind of nice. So again, Mongo is very user-friendly. I don't have to configure and set up this database before I use it. I just tell Mongo what I want this database to be named, and it's going to build it for me as soon as I save that first thing to the database. So it's just a nice little kind of quirky feature of Mongo. Let me put that back to students. Cool. I'm going to stop my screen share. Just want to make sure that you guys are solid. So we have 7 thumbs ups. Yeah, if anybody's having any issues or something, feel free to come on mic and we can troubleshoot. And if you're getting any kind of connection error message or something, I'll put the mongod command here. Make sure you're running mongod.
Mark, since I'm not getting no errors, that means I don't have to run mongod, right? I must have installed something before.
Yeah, if it's running in the background, yeah, you should be good. If you encounter any errors, let me know. Yeah.
All right, cool. Thanks.
Yeah, so for example, my Mongo engine is running in the background, so I don't have to open a tab that tells me it's running. The feedback that tells me that it's connected successfully is that database has been connected message. So Mongoose is telling me, yeah, I was able to hit your Mongo database. I'm communicating with it. We're all good.
Is there a reason why we're using Node and not NodeMon?
Well, so NodeMon is really great. No, don't run it here because NodeMon is really good for front-end stuff, I find. Like if you're updating views or if you're updating client stuff. For what we're doing here, it's just a little bit more efficient for this lesson just to use Node. because we're going to be making some pretty robust changes to our database and then refreshing. But everything that we're doing is like server side. So I find that using the node command is a little easier. Node-mon is excellent, and I use that a lot for like if I'm serving HTML, CSS. That's really the great advantage I find for using node-mon. I guess you could use it here if you wanted. But we're going to be doing like some starting and stopping and refreshing, so I just want to do it a little bit more manually.
Mark, what's our localhost supposed to be? Is this supposed to be reminders?
Yeah, reminders. I'll put that into Slack as well. And again, I did paste all that code into Slack. If you look up a little bit up in the Slack channel. So yeah, you guys should have localhost / reminders. That's going to be your database. Osho. All right, cool. So we have 14 thumbs ups. If anyone has any snags or issues, please ping Christine, and we'll get that taken care of. Cool. So, yeah, go ahead. Somebody coming on mic?
Oh yeah, one quick question. This one says like, dot once. That's like something that's like listening for something to happen, right? Like, it seems like most of the stuff we've done, like, this happens, that happened. Like this is like kind of out there in terms of like, is it just constantly pinging the database to see if it's on?
Yeah, this is just.
Sorry,
yeah.
Does that make sense?
Yeah, I think so. So, we're just looking at like 2 instances of Mongoose methods, the .on and .once. I mean, there's a lot of these if you go through the documentation. But .once, again, I just want to print out kind of a handy message for myself, and I just want to print it one time, and it's whenever I connect to the database. I want a console log that says database has been connected. Now, I don't have to have that in there, but I just want some sort of confirmation that there aren't any errors and issues.
I guess my question is like, why isn't it on db.on open? Why is it db.once open?
Just the method I chose to use in the documentation, just how they recommend setting it up.
Okay.
Yeah. I'm not overthinking the console log message there. That's really just for my FYI.
Curious question, Mark.
Yep.
Okay, so I had mine working, and then I realized that you had pasted this code into Slack. So I erased my code and replaced it with your code. And I went to my terminal, and I did the node database / schema.js again, and nothing told me that it was connected.
You ran database / sorry, I'm a little sorry. You want to share your screen? We'll take a quick look.
Yeah, sure.
Yeah. Also, Farouk and Adam setting the database to authors. So it could be authors or reminders. I know I pasted reminders into Slack.
It was running, like I had it just written out, and then I noticed that you had like a little altered version of the code up here. So I just decided to go with that, and I copied and pasted it into here instead.
You just got to Control-C, close it out, and then reopen it.
Do I have to close it out and reopen it for it to do it again?
That's what I did.
Yeah.
Did the same thing I just did.
Yeah.
Okay, cool.
Yeah, so
I thought that Mongod would handle all that, but I guess not.
Sorry, I just want to answer Farouk and Adam's questions. The code I pasted into Slack, the database is called Reminders. This is part of like a bigger app that we're going to work on later in the week with views and all that kind of stuff. And I'm going to give you guys some starter code for that probably. But your database, you could call it Reminders or Authors, either one. I know that I said authors. So if we really want to be specific, students and authors, because I'm creating students that have many projects. You guys are creating authors that have many reminders. So if you really want to be proper, maybe just change that to authors. Otherwise, it just may get confusing with the reminders. So I would just suggest, and that's my bad. That's kind of from the app we're going to build later in the week. So just so we're on the same page, if you guys want to change your database to authors, That'll be fine. Maybe that'll help make a little bit more sense. So students, you have authors. I'm creating new projects. You're creating new reminders for your authors. So yeah, sorry about that one. Didn't mean for that to be confusing. And actually, once you set that up, that's pretty much the only time we're going to have to touch that. We haven't created any data yet. So if you guys happen to have that reminders path, it probably didn't even create that database because we haven't done anything with it. So we should be fine. Okay, let me move forward. So we talked about one of the beautiful things about Mongo and non-relational databases is that we don't have to create schemas, right? We don't have to have a structure to write data to the database. It'll just take whatever properties, values we want to put in there. So that's Mongo, and that's really great. However, one of the great features of using something like Mongoose is to have a little bit more data consistency. So if I'm going to create new instances of a student, it probably behooves me to maybe put a little bit of a structure for what I want the ideal student, the model student, if you will, to look like. So I want my students maybe to have a name, maybe a email, GitHub link, location, things like that. If there's anything that I want to be consistent across my data, that would be a good indication that you may want to create a schema. Another great reason to create a schema, which we'll talk about later in the lesson, is for data validation. So if we just write stuff into Mongoose without any validations, let's say that we have a telephone number field, what's to keep our user from putting in their email address into the telephone number field and putting their telephone number in the email field or something? We really don't have a way to prevent that just using Mongo as it is. The great thing about Mongoose is that we can create validations. So make sure that my telephone number has, like 10 digits in it. Make sure that my email address has some regex pattern matching. Make sure that it has like that @ symbol, markwright@gmail.com. Make sure it has like a .com in the email signature, in the domain, or maybe a .org, whatever you want. But validations are a really great way to make sure that our data meets some requirements before we actually write it into our database. We'll get into that a little bit later. But let's take a look at creating a schema in Mongoose. So what is a schema? So everything in Mongoose, one of the great reasons to use this is because we can create schemas for our models and our data. Schemas are used to define attributes and structure for each individual document that we're going to create. And each schema maps to a MongoDB collection and defines the shape of the documents within that collection. So that's a little bit of jargon. Let me put in a screenshot, and maybe this will be a little more helpful. If you scroll down to the README, it's just like the section below, but I'm going to go ahead and paste it in here. So here's a kind of a diagram, a crudely drawn diagram of Mongo, Mongoose, schemas, models, and such. So if you want to take a look at that in Slack. So over here on the left-hand side, the application side, let's say that we're going to create a schema. So again, a schema is just kind of a set of instructions of what we want each individual student or project or author or reminder to look like. What fields do we want it to have? What properties do we want it to have? Now, we'll create a schema file, and that's going to compile into something called a model. We saw this at the top when we looked at the example of creating new cats from the Mongoose documentation. So we're going to turn that schema into a model, and then it's pretty much like a constructor function. So we can create new students or new projects. So it's a really powerful pattern. So once we have a model can map to a single instance of something, and a model can also map to an array of those instances. And then on the right-hand side of the diagram, you see the database. So a database, in my example, I'm going to have a database called students. And in that database, I'm also going to have a collection called students. So the database is called students, and I'm going to have a collection of individual students. And then you can see how that collection is kind of like a manila folder, if you want to think about it like that, kind of a collection of documents. So within that collection, there's single documents and there's also subsets of documents. So go grab me all of the students that have the first name Mark, or go grab all the students that live in Georgia or something. So we can get subsets of those documents within that collection. So maybe that diagram helps to kind of helps with the jargon here. But anywho, back to schemas. So let me share my screen, and I'm going to kind of walk through creating a very basic schema for our projects and students. So I'm going to share my screen again. So I'm going to add this stuff here at the bottom. Now, eventually, we're going to like take out some of this code and dry it up and put it into separate files. But for what we're doing today, we're pretty much just going to be dumping stuff into schema.js, which is totally fine because we're not really adding views and express today. So this is totally cool. So from the README, I'm going to type this out longhand. So the first thing we're going to do is I'm going to grab the schema module from my Mongoose module. So schema is kind of a module or library. It's part of Mongoose, and it has a lot of great features. And so Mongo knows what to do when we create a new schema. Again, schema is going to compile into a model for students and projects. That's kind of where we're headed. But it all starts with this very powerful capital S schema functionality from Mongoose. The thing on this next line is really important. I think this will make more sense when we get to relational databases. But we're also going to grab the object ID from the schema. So this is essentially, we're grabbing the schema information from Mongoose, and then from schema, we're going to grab the object ID. Object ID is going to create that crazy BSON hash, the crazy ID for each object. So relational databases are really nice and user-friendly. Like, I guess one advantage of relational databases is just like an Excel spreadsheet. So when we create new students, they're assigned IDs sequentially. So it goes 1, 2, 3, 4, 5, 6, etc. It's very nice and neat. Well, Mongo doesn't do that. And you guys probably saw that yesterday. So Mongo has like a 16-digit, different characters, different type of identification. Part of the reason that it's such a weird, funky ID is so you don't accidentally like try to write the same object ID more than once. Sometimes in relational databases, it can be easy to like accidentally try to overwrite the student with an ID of 1 or 2. Sometimes that can get a little tricky. But with Mongo, luckily, that object ID of 16, 20 characters, it's so crazy that it's going to be hard to like accidentally like overwrite that ID. And so that's how, I don't know if you guys talked about it yesterday, but if you look at the documentation, that crazy object ID, there's actually a method to the madness. And so it's kind of like a credit card number, right? So like the first 4 digits tell you if it's Visa, MasterCard, American Express, and such. There's a similar method to this object ID. It's not just a random characters. There is a method to it. So these are the first 2 things we want to bring in. And then we're going to declare a schema for project and student. And to do this, I'm going to create the project schema first. And the order for this does matter. We'll talk about it here in a minute. But since projects are going to be, they're going to belong to a student, I need to make sure that I declare my project schema before my student schema. And we'll see that just here in a few more lines of code. So I'm going to create a variable called project schema. And this is kind of a constructor function right here, right? So it's essentially, I'm creating a new instance of this schema that I just brought in. And so that's going to give me all of the bells and whistles that schema has within the Mongoose library. So down here, I can declare what fields I want. So for project, I'm going to keep it pretty light. I'm going to give it a title, which is going to be a string data type. And then I'm going to give it a unit. So unit 1, unit 2, unit 3, whatever. And I'll make that a string as well. Yeah. Cool. So this is what I want each new instance of a project to look like. I want it to have a title of a data type string, and I want it to have a unit field that'll be a data type string as well. Pretty bare bones. So let me create my student schema.
So that project, like, it doesn't have to be camel cased. We can capitalize the first.
Yeah. So yeah, that's a really good point. So when we talk about creating models and instances of things, generally you want the entire variable capitalized. So we don't necessarily want to do camel case when we're dealing with models and schemas, because we want our application to know, not only the application, but mainly the people reading the code, that when they see capital P project, capital S schema, they know that that's kind of a proper, schema or a model. This is like the ideal, what we want a project to look like. So we want to keep this all uppercase. That's going to be the same convention when we get to Rails as well. So not only does it have kind of an important Mongoose reason to do it, but also for the user. So there's a difference between creating like a new capital P project or a lowercase p project. It's just a way to know that this is the proper, what we want every project to look like because it's capitalized. So let me finish this up here. So I'm going to create a student schema. And notice also that these are singular, right? This isn't projects schema. This isn't students schema. This is what I want each project and each student to look like. And that's why it's singular. That's really important as well. Models are singular. Student schema, let's put a name. I'm going to make that a string, and then we'll do an age sting. Man, I got fields of gold on my mind or something. And then age is going to be nothing but a number, so we'll put that in there. Cool. So to sum up, it's right here, this kind of like grayed out text. So we're pulling in object ID, and we need to pull this in specifically so Mongo will assign that crazy bson hash to each new instance, and that's how it keeps track of the individual projects and schema, projects and students in our database. Let me do a quick timeout right there and just see if there's any questions before we move forward. So I want to flesh out this schema, and then we'll pause and let you guys create your authors and reminders. Any questions about what we did so far? Go ahead.
We don't know why project's ahead of student yet, right? We haven't gotten there.
We're going to get there in a few steps, but the important thing is that since project is going, so each student is going to have instances of a project. The project is going to belong to a student. So the student needs to know about these projects before, so we need to put the schema for project before the student, because in a second we're going to put, actually we're going to create another kind of something that looks like this. So we're going to create another field on student called projects, and that's going to contain an array of all of the projects that that student owns. So when we set this up in a few more steps, obviously we're pulling in the project schema into our student schema. So this has to exist before a student can pull it in. So that's why like project schema needs to be declared and defined before student. We're going to get to that here in a few steps.
And anywhere you're writing student, we should be writing author. Is that correct?
Correct. Yeah. So I'm doing project and student, and in a few seconds, a few minutes, you guys will do authors and reminders. Author and reminder. Yeah. Cool. So this is considered the schema, what we want these to look like. Remember that schemas compile into models, and models are, for all intents and purposes, constructor functions that we can then create new instances of a student or a project out of. So let's see how we compile a schema into a model. So let me get a little bit of space down here. So the way that we do that, we declare, so I'm going to create a student model. And this is going to grab the model method from Mongoose. So it knows that I'm going to compile something into a model, and I'm going to name that model student model. So then I can do new student model, name equals Mark or Sean or whatever. So student model equals Mongoose model, and Mongoose model takes 2 arguments. So the first argument that it takes, we put it in as a string. This is the name of the database, excuse me, the name of the collection in the database where we're going to store these model instances. Now, we can make this singular because Mongoose automatically assumes that in the database it's going to be plural, because collections in our database are always plural, right? This is a collection of students or a collection of projects. So in Mongo, this is going to be the students collection. And then we pass in the schema that we want to compile into this model. So for this one, it's going to be student schema, like so. So whenever I create a new student model, Mark or Christine or whoever, it's going to grab Mongoose model, and it knows to look in the student schema and say, okay, when I create a new student, what should the data look like? Okay, I know that it needs to have a name, I know that it needs to have an age, and I know that the name needs to be a string, that the age needs to be a number. So yesterday with Mongoose, we could have created an age field and put in a string or put in a Boolean value, and it would have been fine. But now we're just trying to tighten up our data. So down here, let me create a project model. And this is going to be very similar. This is going, actually, we don't need to put that in quite yet because we haven't, in the next step, we're actually going to embed these projects into students. So let's put a pin in that for just a second. I think we're at a good place to stop and let you guys catch up. So let's do that actually. Let's take 5 minutes. Go ahead and create schemas for reminders and authors in your application. And we'll take a few minutes and let you guys get caught up and put this into your app. I'm going to paste this into Slack so you'll have it for reference. Again, I would encourage you guys to type this out longhand, just so you get some habit, get some practice with typing it out, and really think about how all these pieces fit together, because I know that we're throwing out like schemas, models, collections, databases.
Yeah, basically anywhere there's a student, it's an author, and anywhere there's a project, it's a reminder, pretty much, right? Yeah.
Right. That is correct.
What about title, unit, name, and age? Is that?
Oh yeah, let me give you guys that as well. Because I'm actually a little bit early on this you-do. But let me put this into Slack. Yeah, we haven't officially embedded the documents yet. We'll do that in the next step, but let's just take a minute and let you guys get caught up with this code. So I want you guys, your reminders, just have it, give it one field called body, and that can be a string data type. And then your author schema, give it a field of name, which is a string data type. And then don't worry about that reminders will be an array of reminders. You can go ahead and like, I guess, if you want to like pseudocode it or something, just put reminders, colon, and then just do an empty square bracket. We're going to do that next. But yeah, those are the two fields that you'll have for author. And then if you look in the README, there's a link to the solution code. So if you get stuck or anything, you can look at that for reference. And let's do this. It's 12:23. Let's take a little bit of a break as well. So let's take 10 minutes. Go ahead and take a break. Get this code up to speed, and we'll come back at 12:33 and we'll move forward. So go ahead and take a little bit of a break time while you're doing this.
Hey, Mark, are you there?
Cool. So before the break, we were super close to actually persisting data. We're talking about something called embedded documents. So I want to add that little piece of code, then give you guys a chance to add it, and then we'll actually be in a position to start kicking the tires and writing stuff to Mongo. And we can make sure that you guys have all your code clean and up to date and such here shortly. So the last piece of the puzzle, and arguably the coolest reason to use NoSQL, Mongo in particular, is this idea called embedded documents. Now I know that we haven't gotten into relational databases yet. We'll do that in Unit 4. But this is really the great fast advantage to using Mongo in a NoSQL database. So for example, I'm creating students that have many projects. Now in a relational database, I would probably have, if you're thinking about an Excel spreadsheet, I would probably have like a students spreadsheet with all of my students, and then maybe a projects spreadsheet with all of the projects that all of the students have created. Now, as only 2 spreadsheets, I can create some queries like, hey, go find Mark the student, and that instance of Mark is going to point to all of my projects in this other spreadsheet over here. But sometimes it's not super fast and efficient. What Mongo is going to do is it's actually going to, instead of creating a separate projects database or project spreadsheet, if you will, what if I just put those projects directly on my Mark the Student object? Won't that be a little faster and quicker? So instead of like searching all over for projects or whatever data you're looking for, what if all the data that pertains to me, a student, was actually included in my document? That's the idea of what embedded documents do for us. It's super fast because the database doesn't have to search all over for this information. It's all embedded within the most important object of student. So let me add a few more lines of code, and that's what we're going to do with our students and projects. So let me share my screen. And we're almost at the finish line here. The next thing that I want to do is I need to finish creating a project model from my project schema. So I'm going to do that first, and it's going to be pretty similar. So I'll create a project model, pretty much the same pattern as right above for student. And I'll do Mongoose model. And this is going to be called project. And I'm going to create this from project schema. And just to be consistent, I'm going to move that right above student, just so my student will know about it. The really important thing is that your schema, the schema that you're going to embed, comes before what you're going to embed it in. Down here, I'm just kind of being proper. It doesn't matter so much, but it is a good pattern just to kind of keep them consistent. Cool. So I created my project model. Now I'm going to create a field on my student itself, and let's call this projects. So again, instead of creating like some other collection with projects, I'm going to have to like find the projects that belong to a particular student. Yeah, go for it.
Sorry, I didn't know that I was on mic.
Okay. Just popped out of a breakout room, huh?
Yeah, pretty much. My bad.
Okay. So what we're going to do is we're going to create an array of the thing that we're going to embed. So I'm going to embed projects on my student. And then we're going to create this cool little Mongoose array. And within this array, we still want the project to adhere to some sort of structure or a schema. So I'm going to tell Mongoose that this is going to be an array of projects, but I do want each project to adhere to this project schema above it. So that's the magic that's going on here. But this is a super powerful pattern because when I look up, let's say, Mark the student, I want to find my projects are right here with my name and age and email and all that other information. So it makes Mongo super fast. It doesn't have to do a lot of searching or heavy lifting to find the data that we're asking for. So that's pretty much it for embedded documents. Let me put just a couple of quick advantages and disadvantages. So advantages to this pattern is that it's easy to conceptualize and set up, and it's super fast. A disadvantage is that it sometimes doesn't scale well. So one kind of drawback to using a Mongo database is that each document has a maximum file size of 16 megabytes. Now 16 megabytes is a lot of information, so we're probably not going to hit that limit, but it's just something to keep in mind as you scale up and as you become the next Facebook. Eventually, you're probably going to overwhelm that 16 megabyte file size, and you're probably going to need to like rethink your data, maybe parse some stuff out. So just something to consider. Now, before you guys add that, I'm going to put in this one extra section just so you're aware of it. So I talked at the beginning of the lesson that if we want to have like a student has many projects or a project has many students, or students have many projects, so maybe for your group project, several of you students will own a project, and then that project will belong to many students. This is more of a relational database type of data structure, and we're going to save this conversation for when we actually get to relational databases, because that's the most proper time to use that type of database, is when we have those complex data structures. But I just want to mention before we move forward that you technically can bend a NoSQL database to your will if you really want to. You can mimic a relational database type structure in Mongo. We're not going to do that because we want to use Mongo the way it's intended, just to kind of get the most out of it. But I just want to put in this screenshot to let you guys know that if you do have a more complex data structure, let's say that you did want to create a separate projects collection and a students collection and keep them separate, you can set that up that way. And this screenshot talks about creating two separate collections that are connected. And I'm just going to put that in here. We're not really going to see an example of that, or we're not going to code out an example, because we find, or really if you're getting this complex, you're going to want to use a relational database. It's just going to make your life easier. But you can use Mongo for that purpose. So I wanted to put that screenshot in there. Okay, moving on. So let's take a few minutes and you guys add a reminders model to your app, and then add that reminders field to your author schema so that you can embed your reminders on your author. So let's take a few minutes and let you guys get up to speed. And then we should be pretty good with our kind of our data schema structure, and then we can actually start saving stuff to our database. So let's take a few minutes and do that, and I'll put those instructions into Slack. All right, folks, take just a few minutes to set that up, and then let's actually save some stuff to our database using Mongoose. What if I put 2 Mongoose modules in my app? What would they be called? Mongoosen. Mongoosener. Any other thoughts? Not that you would ever want to do it. I don't know if it'd be called like Mongoose or something. Yeah, I guess I was thinking Mongoose. Mongai. Well, hopefully it doesn't come to that. Hopefully we don't accidentally put 2 instances of Mongoose in our app. Okay, cool. I'm going to move forward. Let me show you guys some examples of how to persist data to the database, and then give you guys an opportunity to do that with author and reminders. So let me share my screen, and let's do this. So there are 2 ways to actually write something to the database. You can use new and save, or you can use a method called .create. And these are the same methods that we're going to use in Ruby and Rails. So the good news is when we're dealing with these types of ODMs, object document mappers, frequently the methods are going to be the same no matter what stack you're working in. So that's kind of a silver lining. Let's take a look at how to do the first way, where we do new and save, for example. I'm going to put this code underneath my other stuff. Again, it's in a minute we're going to put all this into like seeds.js. I'm going to give you guys some seed. Actually, you guys are going to create some seed data. But the first thing I'm going to do is I'm going to create a student named Anna. And I can use my new student model right here, because I'm going to create an instance of a student. And I want the student to look like the schema right here. So I can do a new student model, and I'm going to make her name Anna, which is a string. And we'll do like an age 30. So with new and save, it's 2 separate steps. So I just created a new student model named Anna, and I'm assigning it to a variable named Anna. So I create this new Anna, but I've not yet saved it to the database. So one reason to potentially do this, let's say that I created a new student named Anna, and then maybe afterwards, maybe I want to do something like, oh, let me add an age to Anna, like after the fact. So if you have some sort of situation like that in your logic, then maybe you want to do the new and the save. So new would kind of instantiate a new object, but it hasn't persisted it to the database yet. So in the meantime, you can do other stuff with that data. I'm going to go ahead and put name and age on Anna there. And then the next step is actually need to save this. And so kind of the pattern for saving new data, so we'll call .save on Anna, and save takes a callback function. And it takes 2 arguments. The only argument that's absolutely necessary, I think, is the error argument, just in case there's something blows up. But then you can also pass in the actual data that you're writing to the database. So that's the second argument. You could call this data, you could call it document, whatever you wanted. Traditionally, maybe it makes sense to call this, a singular instance of what you're creating. So in your lab time, I think you're going to use docs, for example. Docs meaning document. So this could be anything. I'm going to use student for now. And so the pattern here is we want to add this error. And this is from the documentation. So if I have an error, go ahead and let me know about it. So console log the error. Else, go ahead and return the object I just created. So we have to tell, unfortunately, we have to be really explicit with JavaScript. So we have to tell Mongoose, or JavaScript rather, once I create this thing, if there isn't an error, just print it out to the console just so I can confirm that it actually worked. So that's what this code is doing here. And this is a pretty standard kind of if-else statement for creating new Mongoose instances. All right, so I saved that file. Now what I'm going to do is I'm going to run my schema.js file. So I'm going to go node and then db, because this file is in my database folder. And I'm going to run that. I get that database has been connected message, that mongoose.once that we did earlier. And then I can see that it's returning that object, that new student object named Anna, and the age. And then I know that it persisted successfully because I get this object ID back. Now, if this didn't save or if something happened, Mongoose, in Mongo rather, would not have actually saved it to the database. But once I have this object ID, once it's been assigned, I'm pretty confident that it's been tucked away into the database. So that's a good sign. And note, again, once I run that file, I'm still getting this little blinking cursor. So I'm still kind of in a state of limbo because I haven't closed that database connection. You can add some code that will like exit your database once you've done something inside it. We haven't added that code yet. So I just want you guys to be aware that when you guys run this file, you're going to need to Control-C just to get back to the prompt, okay? So it wrote to the database and it's still like kind of hanging out in there. So that's how we use new and save. I'm going to just paste this into Slack. You guys will have a chance in a moment to use a .create. So .create, if you want to create a new object and save it all in one fell swoop, you can use the .create command. So notice that this is a little different. So with .create, we don't have to assign this new instance to a variable. So previously, I created a new student and assigned it to Anna, the variable Anna, because I had to call .save on it after I had kind of instantiated it. With .create, you don't have to do that if you don't want to. So we could go straight to student model .create. You can pass in the fields that you want for this new student. So it's just a little bit more concise. One thing about the new and save versus create is that new and save, sometimes that can give you a little bit more flexibility if you want to do some testing. So maybe I want to test this new object before I save it to the database. So maybe if you're writing tests, or maybe if you're going to do some validation checking and such, sometimes you want to separate that into two separate devices if you want to add some, if you want to be a little bit more flexible. But you can certainly use this .create. So let's take a look at one more example of creating a new student and embedding a project directly onto that student array. So if you notice right here, Anna has a projects field, but it's just an empty array. We haven't added any projects, any project instances to Anna. The cool thing about this, since it's JavaScript, is we're essentially just going to do a push onto this array. So projects is an empty array. It has all the properties of an array data type. So we can call a .push on it. And that's really going to be the magic in this next little step. Before I do that, I'm going to, because I think I'm going to get an error if I try to create Anna again. So just to be completely safe, I'm going to just blow up that database so I don't get, I'm assuming I'm going to get an error, and I don't want that to happen. So I'm going to grab my students database, and then I'm going to drop database. Now later in the lesson, we're actually going to write some code in our seeds file that's going to like delete all the students and all the projects before it seeds that database with new data. But right now I'm just going to blow up the database before I do this next step, just in case I get an error. So let me get rid of this stuff here, and I'm going to follow along just from the README. So let's take a look at adding an embedded document. What would that look like? So I'm going to stay with Anna, and let me create a project for her. So project 1, and this is going to be an instance of my project model. This has properties of title and unit, pretty basic. So we'll do title, memory game, or connect 4, whatever you guys want. And then unit, This will be like the JavaScript unit. Cool. Oof. We need to make that a little cleaner. Cool. So I have an instance of Anna, which is a student, and an instance of a project 1, which is an instance of a project. Now let me kind of connect the two. So once I create Anna on line 35 here, Anna has this projects array available to her. And again, right now it's just an empty array because I haven't added anything. So the cool thing is I can call .push on that, and I'm going to add project 1 to her array. And I still haven't saved Anna to the database, right? I created a new Anna and a new project, but I haven't officially persisted this in Mongo. So I added a new project to Anna's array, projects array. So now I'm going to do Anna.save. I'll pass in the callback function. And this is just a pattern, and the more that you type this stuff out, it'll just, you know, be a little easier. So the pattern is I want to do, just in case there's an error, I want to print it out. Otherwise, just go ahead and console log my student. Now, once we start adding views and forms and such, maybe I don't want to console log my student and such because I'm going to see that in the browser, and that's fine. But since we don't have any views, I just want to confirm that the student is actually being persisted. And I also don't want to necessarily go into my Mongo database each time and pull up the database. So just a little bit of a convenience thing for us. So I have it closed off down there. Cool, so that looks pretty good. Let me run this code. So I'm going to do my node database schema file. So now when I run this, cool, so it looks like it persisted my Anna student object. And now I have that one embedded project document in Anna's projects array. So I just have one project right now. And notice that the project also got an ID. So this is going to come in really handy later. Even though the project belongs in the Anna document, let's say that I wanted to just grab all of Anna's documents, if I wanted to grab all of Anna's projects, or maybe I wanted to return like a specific project of Anna's, I could still do that by grabbing the ID for that project. I would just need to go to the Anna document, then look in the projects array, and return the project for unit 1 or unit 2, a specific project at that point. But that's how we add embedded documents to some other document. It's a pretty powerful pattern. And again, if I want to find Anna's projects, they're all embedded directly on Anna, the document. So it's super, super fast. So I'm going to stop my screen share. And I'm going to give you guys some time to add this to your application. Any questions before you guys embark? We'll take maybe 10 or 15 minutes and let you guys play around with this stuff.
Mark, just to be clear, for the .save, the second argument is always the database you want to put it in, right?
For .save, the first argument is the error object.
Sorry, the second.
The second is the actual data, that you're persisting. So in my examples, I wanted to pass that student data for Anna. I wanted to console log it or do something else with it. So I passed that into my callback. You guys will probably want to pass in author, into your callback.
Where's the variable student in your code?
I called it student because I was creating a new student.
But it could literally be any string in that second argument?
Yeah.
Okay.
You don't put it in a string. You just put it in there. It's a kind of the name of the data object. You can name it data. You can name it document. You can name it whatever you want, whatever you're comfortable with, whatever convention you want to use.
It seems like an undeclared variable. Can you reference author other than within that function, or no?
Well, it's not an undeclared variable. It's just the argument. So the data argument is the second argument listed in that callback. That's just how the pattern. That's how the .save method works. So in the .save, let me paste this in the Slack. So I just pasted into Slack like that Anna.save few line block of code. So .save takes a callback function. That callback function takes two arguments. It takes the error and it takes whatever data that you're trying to save. So error, again, you could call that ERR, you could call it ERROR, just using ERR for shorthand so I don't have to type error all the time. But the second argument is the actual piece of data, the actual object that you're trying to save to the database. So if you want to do something with that data, if you want to console log it, eventually we're going to be passing that data to our views, right? Because we're going to like wrap that into a render function and send that back to the browser to see what we just created. But I'm using student. You can name that anything you wanted technically. So maybe you want to call it author because you're creating authors and reminders. But you could call it data. Sometimes you'll see document or doc because you're literally creating a new document in your database. So it's really whatever convention you want to use.
So whatever's before the .save is equal to student, right? So Anna is student in this case?
Anna is only equal to student because that's what when I created a new student, I just assigned it to the Anna variable.
So if it was Bob.save, student would be Bob.
Yeah.
Okay.
Yeah, student is just more generic. So if I was creating like 5 students, I don't want to like pass in Bob or pass in Anna. I just want to do Anna.save student, Bob.save, pass in student. It's just a little bit of a drier convention. Actually, our next step, we're going to create some seed data. So you guys will put some data into your seeds file. And so in that file, you want to be a little bit more generic with what you're saving because you don't want to have to write like Anna's name and Bob's name and Tom's name and what have you. Yeah, so I just put the udos in there. You guys are probably already through it, but just practice create a new author using new plus save, then create a new author just using .create. Again, it's going to do the same thing in the end. It's just a little bit more of a concise way to do it. And then see if you can embed a reminder document inside of an author. And let me know if you have any questions or issues on that. If you don't mind, give me a nice cheesy thumbs up in Slack if and when you get those 3 tasks completed. And I'll pour some water out for Tom.
Yeah, was that Jamaican or?
That was awful. God. I'm working on it.
When it comes to accents, you're an amazing programmer. Tell you what.
I hope I'm a better programmer than I am an impressionist. Well, you know what it's like living in the South. It like the Southern accent. It's just like so the drawl. It's just hard to get like to formulate stuff. My New Zealand accent is just fine. So Kelly asks, what is _V? So that's a very good question. If you look in the Mongo documentation, Mongo does, this is like a little bit more like intermediate and such, and you'd probably need to check my math on this, but so Mongo has a type of indexing that it does on its collections and documents. So one way that it's a little bit more efficient is that it can tell if a document has been updated. So indexing is when it like, kind of like indexing in a phone book, how like it'll have, or maybe the index of a book, right? So it has like the topics in alphabetical order, so you can quickly find that portion of the book if you're just looking for something specific. So _V in Mongo, it keeps track of how many times a given array has been changed or updated. So it's different from every time, Colin mentioned yesterday about adding like a created at and updated at fields to your database, which can be very helpful. Now in relational databases, the one we're going to use, Postgres, does all that stuff for us. We don't even have to ask it, and it's going to do it. But this _V, that's different from every time the document changes. It's very specific to the array. Specifically because an array doesn't necessarily, sometimes the array can be, remember arrays, you find objects in an array by index. So if you save, remove stuff from a given array, maybe the order of those objects within the array changes. So one way that Mongo can kind of make sense of that is that it keeps track with that _V, and that tells like the Mongo engine, hey, this thing has changed since this array has changed since last time that you accessed it, and maybe the objects in the array have moved around or something. So it's just a way that Mongo keeps that stuff straight. I hope that was helpful.
I have a question.
Sure.
For that create way to do it,
Mm-hmm.
How do we embed? Do we still need to like declare the name of the person and the reminder to embed it, to do that push?
That's a good question. So it's not quite as easy. It's not quite as flexible when you're doing create. So what you would need to do, well, I would suggest if you're going to embed the document, use the new and save. Do it in 2 separate steps because it's a little easier to do that. And actually, when we put views in our full CRUD, we're going to do it in 2 separate steps. Again, it's more flexible that way. But if you're going to do a create, there's 2 ways to do it. You could create the author object and assign that to a variable, and then like attach a reminder to it, and then update it or resave it. Another way you could do it is create that author in the database, and then find that author by its ID, by that crazy BSON hash, and then push a new reminder into that person's array, into that author's array of reminders. Yet another way would be actually in the create, the .create, remember it takes arguments for what you want that author to look like. So one of the fields would be a reminders field. So you could just create a reminder, within that field. Remember that a reminder is going to be an array of reminders. So you need to do the square brackets and then put individual reminder objects within that array. That gets to be a little more, it's just a little bit more complicated to type out, and it's really easy to make semantic mistakes or grammar mistakes. So that's why sometimes it's easier to code it, create the new author with a new, assign it to a variable, then you can just push new stuff in there. It's a little bit more flexible.
So because what I did is I created one with the save, and that one was okay to, like, I was able to embed it just fine. And then I created a different outer with that create, and yeah, it just got weird. But I figure since we already have like the object with the name and the age, might as well just do two objects and put the reminder in there. Can I do that? Just put an array with the two objects.
And then add it on to that specific author that you just created?
Yeah.
You could do that, but once you use .create,
Mm-hmm.
you're going to have to go back into the database and grab that specific author to push the new reminders onto his or her array. So you're going to have to find the ID of that author, then go back into the database and find me the author with this ID, with this crazy BSON hash, then push these new projects onto that author's reminders array. Another way, now that I think about it, probably in the callback, in the create callback, maybe when you pass the data down, so you're passing an author into the callback, you could probably, in that if-else statement, you could probably do author.push, because you would still have that specific author kind of there in the callback. So you wouldn't have to ping the database. You could just do author.push and then push in some new reminders, and then but you would probably need to do a .save again.
Okay.
Sorry, I know that's a little
better.
Yeah, the .create is good if you're just creating one instance of something and you're not embedding data. If you're going to do an embedded document, it's much cleaner and it's easier to code. It's easier to kind of follow the logic if you do the new and the save. Okay. We're going to see that in a minute when we create some seed data. You guys are going to create several instances of authors and reminders.
All right, thank you.
Sure.
Hey, Mark, I had a quick question.
Sure.
I tried to save one reminder to two different authors, and it works, but I was just curious that I have to do a .save on both authors, right? Because I realized it doesn't work without that. Is there a simpler way to do it?
Yeah, that's a really good point. Let's break this down. So with embedded documents, think about if you have, if you're married or whatever, and you have a joint bank account. So let's say that husband and wife are two documents in your database, two people documents, but they share a bank account. So where would you save the bank account if you were going to embed the bank account? They both share it. So would you embed that bank account on the husband document? Would you embed that bank account on the wife document? How would you do that? It's very similar to what you just described, in that you're trying to save one reminder to two authors. So you wouldn't want to do that with an embedded document. That would be an example of kind of a more relational database type situation, where you would have an authors table or an authors collection, and you would have a reminders collection. And then they could, two authors could share the same reminder. But if you're going to embed a document, it only works if that document belongs to one person. That's really the use case for an embedded document.
Cool, thanks. Just experimenting.
Yeah, that's a really good point. So earlier when we talked about how you can make Mongo kind of replicate a relational database, that's a perfect example of when you would not want to embed a document. Yeah, good question. I like that too. I like that you're kind of playing around with it and seeing what you can get away with. That's awesome. All right, how many thumbs ups do we have? Cool, 6 thumbs ups. So let's take another few minutes and then we'll move on to creating some seed data. So we'll have a little bit more data to play around with.
Hey, Mark, when I try to save it, a reminder, it just keeps an empty array when I do .create. Any idea the hell I'm doing wrong here?
Sorry, say that one more time. That may be related to what we just talked about with how to do .create to create new authors and reminders.
Yeah, so I did it one of the ways, which was just say, comma reminder, and then you put it in. I thought that was one of the ways that was listed.
Did you use new and save, or use .create?
.create.
Yeah, so you would want when you're creating a new author, you would want to have, a reminders field, colon, and then you'll have an empty array to start, right? Within that array, you would want to create an object in curly brackets. You would want to create a reminder, and that array needs to have, that object needs to have all of the information that you put in the reminder schema. So that would be, what did I ask you guys to do for the reminder schema? So it would need to have a body, actually. But like I said earlier, let me look at your screenshot. When you're doing embedded documents and stuff, it's just going to be easier and cleaner to do a .new and a .save. But let's look at what you did. So author model .create. Okay, so this is pretty close actually, but remember that so first of all, looking at your screenshot, so does your author model have a field of reminder or reminders?
You stud.
It's reminders. And remember that reminders is actually an array, and you're trying to pass in a string. And actually looking at your author schema, remember that for this exercise, we want our reminders, we want that array to adhere to the reminder schema. So you'll need to add reminder schema inside the square brackets, inside the author schema, if that makes sense.
Yeah, no, perfect. And I could still just put in string after like reminder semicolon, right? Or do I have to put that in square and curly brackets?
You would need to, you need to create an array, and then within that array, each instance of a reminder needs to be an object. So you need to put that in curly brackets. And then inside the curly brackets, each of your reminders needs to have a body field and then, a string data type. So your reminder would need to have body colon your string. Now remember, remember that Mongo itself doesn't require a schema. So you could, Adam, if you didn't want your reminder to adhere to that reminder schema, Jesus. It doesn't have to. So you could pass in a reminder with a body field and a date field and a duration field or whatever. But if we're playing by the Mongoose rules and we're trying to add some structure to our data, then you would want to create your reminders the way that the schema asks you to create them. So it would have one field of body and then whatever you want the body to be. Let me look at this other screenshot and then we'll move forward. Yeah, that's close. Very close, but what are you forgetting here? What fields does each reminder have? We're playing by the reminder schema rule.
Oh, thank you. Okay,
Yeah.
Got it. Much appreciated.
So, well, don't ruin the surprise. Ruin the surprise. Tell us what you're forgetting for those following along with this.
Yeah, I gotta call it out body, then semicolon, and then the bad point.
Yeah. So do that, and then if you don't mind putting in another screenshot, just in case people are checking that out. Cool. Okay, so let's move forward. We have about 12 minutes to lunch, so let me get you guys started on this. So let's have a little bit more fun creating new objects in embedded documents. We're going to add some code to our seeds file so that we can have some data to play with after lunch. Right now, as far as CRUD goes, we've looked at how to create objects, which is really good. So we can use new and save, or we can just use .create. Then after lunch, we'll go through read, update, and delete. But let's get prepped for this afternoon. So let's add some information to a seeds file. So let's set that up. Let me share my screen, and I'll walk you guys through it. And I'll get you guys started. And if anyone else is still having some issues, I'll stick around and get you guys straightened out. So I'm going to share my screen, and let's add some fun seed data. All right, so we created the seeds.js file earlier, and we're going to start playing with that. I'm going to split my Atom console here, my Atom area. And maybe this will help us out. So I'm gonna drag seeds down here just so we can kind of see both of them. Actually, maybe if I put them side by side, it'll be clearer. Let me do this. So maybe this will be helpful if we can kind of see both at once. Okay, so let's add some seed data. Pop this into Slack. So this is where we are. So the first thing I want to do are handy dandy module.exports, which we're going to use all over the Node and Express and Mongoose Mongo world. So that's the first thing we need to do. So if we're going to export what our schemas should look like, what our models should look like, if we want to have access to those, we need to add a module.exports down here in our schema file. So down here at the bottom, I'm going to create a module.exports object. So we'll do module.exports, and then again, this is just an object that's passed around between other areas of our application. So to keep this really nice and simple, I'm going to create a student model that's going to be the property on this object, and I'm going to make that equal to student model. I'm going to keep this really kind of simple. So the property is called student model, and that's going to be equal to the student model that I define right here. Okay, so when I pass it in, it's going to have the same name in both files. Then let's create our project model, so our other files will have access to it. Cool, so module.exports, student model and project model. So I'm just exporting the two models that I created here to my seeds.js file so I can do some more creation in that file. Cool, so we're going to add module.exports, and then up here in our seeds.js, the first thing we need to do is import Mongoose. So if we want to have access to the Mongoose module, all of the methods and functionality that it has, we need to require it within this file, the seeds.js file. And I'm also going to require my schema file, because my schema file is where I'm grabbing this module.exports model information. So I'm going to call this schema as well. And just so there isn't any confusion, I could name this variable whatever I want, but this capital S schema is not the Mongoose schema. This schema in my seeds.js is going to be the schema file itself. This is where I'm going to grab the module.exports. So I'm going to require, make sure I get the path right. So I'm going to go dot, because I'm in the parent folder, because seeds and schema are both in the database folder. So I'm just going to grab the schema. So again, this schema on line 2, this is not the Mongoose schema. This is just my schema file. So I'll have access to this module.exports. Cool, and then let me declare my student and project models here. So my student model is going to equal schema. And then remember that schema now refers to this module.exports object, because I'm requiring the file. And remember that when I require the file, whatever I attach to module.exports is going to be fair game. I'm going to have access to it. So essentially, it's going to be schema.student model, because I'm going to grab that property off my module.exports. So student model, and then down here, I'll do the same for project model. Schema.project model. And just to clarify, this is essentially the same thing as if I did like, you know, module.exports.student model. It's the same principle, because module.exports is now essentially my schema variable. But it's the same thing. All right, cool. So now I have my models. I have Mongoose required, so I'm in pretty good shape. I'm just going to rip some code out of here because I don't want to type all these seeds. The first thing that I'm going to add is this .remove method. So .remove is a Mongoose method. I'm only doing this, you don't have to do it if you don't want to, but it's a good practice because every time I run this file and seed my database, it's going to add 3 new students to my database. But each time I run this file, I want to start with a fresh set of data. So I'm going to go into my Mongo database and just remove all of my students and remove all of my projects and then reseed them with this fresh data. Otherwise, every time I seed this database, it's going to keep the ones that it had. It's just going to add 3 more students every time I run this file. And eventually that's just going to it's not going to be very neat and tidy. So I'm going to completely remove everything from my database and then reseed it with fresh data. So that's what these 2 lines are doing. And then I'm going to grab this stuff from my README. I'm going to ask you guys to actually probably create a few seeds just to get some practice. But what I'm doing here, I'm creating 3 new students. I'm using the student model. It's essentially a constructor function now, right? I can create new instances of a student. I'm going to create one named Becky, one named Brandon, and one named Steve. Down here, I'm going to create 4 projects. Project 1 is our Unit 1 JavaScript. Unit 2 is Express. Unit 3 is Angular. Unit 4 is Rails. Just some dummy data. Down here, I'm going to add the student instances which I've assigned to variables. I'm going to put them in an array because I'm going to do a for loop to try to just add projects to each student, just kind of do it in a cleaner way. So I have a students array here, and then I have an array of all the projects here. Now I could go down here and hard code, Becky.push project 1. I could do all that. But I'm going to use a for loop just so it'll save me some manual stuff. And essentially what this for loop is doing, it's going to grab each student and it's going to add the first 2 projects to that student. The next student is going to add it's going to increment the project index by 1 so that Becky will have project 1 and project 2. Brandon will have project 2 and project 3. And Steve will have project 3 and project 4. That's just how I'm setting this up. It's just pretty arbitrary. So I'm going to push the projects onto the students' project array, each individual one that I iterate over. Then I'm going to save that student. And then this code is the same as what you guys did manually a while ago, right? This is just the pattern. So I'm passing error and the student object, that new student that I'm saving to the database. I'm passing these into my callback function. If there's an error, just show me the error in the console. Otherwise, print out console log the student data just so I can make sure that it was persisted. The last thing I'm going to do, I'm just going to take out this dummy data from my schema. It shouldn't run that code because I'm only running this file, but it may run it since I'm pulling in the schema. I just don't want my wires to get crossed. The only thing I want my schema to have is literally my schema, and then I'm exporting my models. So remember that a schema compiles into a model so I can create new instances of a project or a student. So that looks pretty good. Let's run this code. So I'm going to Control-C to close out of because it was still trying to run that code from earlier. And now I'm going to run my seeds.js file. Let me make this window a little bit bigger. And this is all the data that it created. So the for loop created Becky in her projects array. She has 2 projects. She has project 1 and project 2. Created Steve. Steve has project 3 and project 4. And then Brandon has project 2 and project 3. Now again, the way that I code it is just interesting side note. So remember that arrays, you can't always count that an array is going to, that the objects inside of an array are always going to be in the same order. And this is a perfect example because the way I coded this, I coded it Becky, then Brandon, then Steve, right? That's the order that I coded the creation of these new students. But the way this was returned is it actually, because it's asynchronous, you can never tell with JavaScript, it created Becky first, then it created Steve, then it came back and created Brandon. Or that's how it was returned anyway, because it did look like it created project 1, project 2, project 2, project 3, then project 3, project 4. So looks like it created it in the right sequence. However, it didn't return that array in the sequence that it was created. So Kelly asked earlier about this _v. And so this would be a perfect use case for why Mongo would use this. So if I kept rewriting this collection and changing stuff, eventually Mongo would probably want to keep track of the order that these items in the array are in. And so it would start, indexing the versions. It would start taking snapshots. So if my code depended on these being in a particular order, Mongo would be keeping track of when things changed. Cool. So we're at lunch, so let's put a pin in it right there. We'll pick this up after lunch. Was someone coming on mic? Was there a question?
Yeah, sorry everybody. My question is... Let
me do this. Let me dismiss you guys for lunch, and then Adam, we can hang out for a second. So have a great lunch, you guys. We'll see you at 2:31 p.m. Eastern, and we'll pick up back up where we left off. So I'll see you after lunch. Go ahead, Adam. Sorry.
Yeah, so we require Mongoose at the top here, right?
Yeah.
Because of course we're using all that stuff, but we're not doing the mongoose.connect.
Yeah.
What's that about?
Yeah, well, so the connect we only need to call in one place. So we're calling that in the schema.js file up here. And we're loading the schema file anyway, so it already knows about it. Actually, that's not entirely accurate. The reason that it knows about it is because we're requiring Mongoose in here as well. So Mongoose knows that we've already called the connect method, and so it already knows about this database. Now, eventually, when we scale this up and put views and other stuff, we're going to put all of this logic in like a separate file that only configures the database and only like opens and closes the database. But right now, we just dumped all of this code into our schema.js. Eventually, we'll clean this up and put it in different files. But for now, that's where we put it.
Okay, excellent.
Yeah.
Thank you very much.
Cool, man.